Hello, good afternoon. This is Mr. Michael Izanata. You're welcome to our first virtual mathematics class. Yes, this is going to be the first in a series of online classes that we'll be having over time. I want to believe that you all are on lockdown. Yeah, you have to be on lockdown as directed by the authorities. If you can help it, please do not go outside. Stay at home. And if there is any need for you to go outside, please, when you do, make sure you exercise every precautionary measures that has been advised by the authorities. Talk of your hand sanitizers, your gloves, facial masks, and even constant washing of hand and all that. And again, maintain social distancing. Yeah, there's a need for that, so that we'll be able to avoid this COVID-19 pandemic that is ravaging the whole world, Nigeria, and even here in Lagos. Okay, so we'll be having our classes through this medium. I'm going to be providing instructional videos, after which at the end of each video I'll give you an assignment for you to do and then submit. I will also try and provide my contact details in case you want to reach out for a follow-up question, or I don't know, for assistance. You can reach out to me, maybe through phone call, text message, or even WhatsApp message. I will be glad to be of help to you in the ways I can. All right. Yeah, the white screen, that's, as you've already seen, that's our marker board, our white marker board. Yeah, so I have a board on my phone. I can write, erase, and all that. For today, this is going to be part one of this video, because YouTube has some restrictions on the video duration, so I wouldn't want to go against that. So I'm going to pause it at some point and then we'll continue the next video. So, but for today, we'll be looking at the topic definite integrals. Yes, that's under integration. So we'll be looking at, let me write it. Don't mind my handwriting, is a scribbling and I'm making, because I'm using my thumb. So this is definite integrals now. Okay, that's definite integrals. That's the topic we're looking at. Definite integrals under integration. But before we even look at that, I would want us to look at the difference between definite integral and an indefinite integral, because we also have an indefinite integral. And before we also look at the definite integral, I would kind of run a quick revision, like a primer, on our basic integration rule, just in case maybe you have forgotten, so you'll be up to date and then follow along as expected. So we're looking at the difference between a definite integral and an indefinite integral. The difference is, let's look at it. Remember that this is your integral sign. So let's say we have two integrals, same function. Say we have 2x plus 4 to be integrated with respect to x. Don't mind the writing. And also we have the same function now, 2x plus 4 to be integrated with respect to x. Now they are the same. Now what will make one a definite integral is where there is what is called the limit or the boundaries. For example, if there should be, say, like a 2 attached here and then a 1 here, this integral here becomes what is known as a definite integral. Why is that so? Because of the limit that has been attached. The 2 in this case becomes the upper limit, while the 1 becomes the lower limit, or you might want to call them the 2, you can call it the upper bound, while the 1 is the lower bound. Whereas the 1 here is an indefinite integral. There is no bound. It can go on for as long as it wants. So, but the one below here, this is the D for definite, while here I for indefinite. So the D, which is definite, becomes, or is called a definite integral because it has the boundary conditions, that is on the lower bound of 1 and then upper bound of 2. And this method also is what we use to calculate area under a given curve, which we are going to look at in later class. But for now, just know that this is the basic difference between a definite integral and an indefinite integral. So having said that, then the next thing that we will want to look at very quickly is a quick revision on a bit of a basic integration rule. Let me clean this up. Okay, now I forgot to add that you might have to pause the video for as long as you want to make some notes. So you pause the video, you make your notes, and then you continue. You can do that as much as you want, yeah, so that you're able to follow along, because I'm racing against time, so I'll have to be as fast as possible. All right, now down to the basics, your integration basics. What do we have? Say you have your integration, an integral of x raised to power n to be integrated with respect to x. The general integration formula states that when you have a function like this, what do? You simply write the variable, in this case your x, and then you add 1 to the power n plus 1. This sum which you get, you use it to divide. That's still the same n plus 1, and then you add plus c. This is the general formula for integration. Then when you have an x, a variable raised to power n, to be integrated with respect to, say, x, in this case, you just add 1 to whatever the power is. The sum you get used to divide, and add your c. And you should also note that the c, you add c only for indefinite integrals. For definite integrals, you don't necessarily need to add any c. You don't add a c. I'm going to also look at that. Okay, now let's look at some practical examples to drive the point home. Let's say you want to integrate x raised to power 5 with respect to x. How do we do that? As I've already stated earlier, following our general integration principle, what do? We simply write our x back, and okay, write our x back. The power is 5, so what do we do to the 5? You add 1 to it, so 5 plus 1 gives us a sum of 6, and that 6, which is a sum, we also use to divide, so x over 6, then you add plus c. This becomes the integral of your x raised to power 5 with respect to x. Let's look at a few more examples. Say we want to, what about we want to integrate maybe 2x with respect to x. How does that work out? Of course, you still write 2x back. Now the question becomes, what is the power of x here? Since there is no number written there, so you can assume, or you should know, that the power is 1. So the power of x is already 1, so 1 plus 1 will give us a 2. The power changes to 2, and of course we use that to the sum of 2 to divide, and then you add plus c. And looking at it, you see that you can further simplify it. The 2 cancels the 2, so what you're left with is x raised to power 2 plus c. Okay, now how about, okay, integration of constants? You can integrate constants. You should remember that constants are they are expressions that have no variable. They have no x, no y, no z. They're just digits, numbers. So let's say if we want to integrate maybe 5 with respect to, let's say, y now, what happens when you're integrating a constant with respect to any variable? What you have to do is the constant will take on the value of that variable, that y, x, t, as the case may be. So when we integrate 5 with respect to y, our integral gives us 5y plus c. When we integrate with respect to x, it gives us 5x plus c. Okay, if we integrate 10 with respect to x, what will the answer be? Well, you guessed it. The answer will be 10x plus c. How about when we want to integrate, for example, we want to integrate 1 with respect to x? What happens? The same way, your 1 takes on the value of x, so you're having 1x, but you cannot have a 1x in mathematics because 1x is saying 1 times x, and 1 times x will give you an x. So integral of 1 with respect to x will give us x plus c. Okay, and then the list goes on. So that's the very basic of integration. Okay, so at this point I'm going to pause the video, and then it's getting lengthier, so in the next class next video I will delve into integration, the definite integral fully. So until the next class, bye.